This is the review for Test 4 in Math 1111, which covers lessons 13, 14, 15, and 16, which covers rational functions, exponential functions, and logarithmic functions, as well as the applications of logarithms and exponential functions. So let's begin. Question 1 says let f of x equal 3 to the x minus 3. What is f of 1? Basically, it's a substitution problem. You're probably definitely going to want to have a calculator nearby when you are working on the review and taking the test. So this is a straight out plug and chug problem. So I will substitute 1 into the given function. So I would have 3 raised to the 1 minus 3 power. 1 minus 3 is negative 2. So I have f at 1 equals 3 to the negative 2. If I continue working that out, we need to convert this to a positive exponent. We do that by taking the reciprocal, so it becomes 1 over 3 to the second, or 1/9. Now, you could put that into your calculator, okay, when you get to the point of having 3 raised to the negative 2 power, but it's going to give you a decimal. The answers are given as fractions, so you can go to math and convert it to a fraction, and it gives you 1/9. Or you can do it by hand as I did. It's almost just as quick. Question 2 is a word problem, and it says a speedboat bought for $13,000 depreciates at 10% per year compounded continuously. What is its value after 7 years? Round to the nearest dollar. So a couple of words here that are important as you're looking at this problem. One of them obviously is depreciates. Okay, because depreciates is bolded, it's italicized, so obviously that's an important word. Also, another word that's important here is the fact that this is compounded continuously. That phrase helps me to know the formula that I should use. And since this is talking about depreciation, we really use the interest formula, which is A equals P times E raised to the RT, where P is your principal, which is the amount that you began with, which in this case we bought the boat for $13,000. R is your rate of interest. In this case, that was 10%. Written as a decimal is 0.10. T is time, and typically time is expressed in years, and we're told 7. And A would be kind of your final amount or your final value. So once you recognize that you need to use that formula, it does become a plug and chug. So if I substitute into this formula, I want to know the final value of the boat after 7 years. I paid $13,000 for the boat. E, and here's where a lot of students make a mistake. Because it depreciates, it's losing value. You have to use negative 10. My rate of depreciation was 10% per year. Depreciate means you're losing value, so it does have to be negative, and we want to consider what happens after 7 years. Okay, so I've substituted into the formula, and then I can do a little bit of pre-calculation. I have 13,000 times E to the negative 0.7 or 0.70. And from there, I really do need to use a calculator. There's not much else I can do by hand. So I'm going to go over to my calculator and type this information in. So I would type 13,000 times, get my E, and I'm going to raise it to the negative 0.7. Again, it's negative because the value is decreasing or depreciating. And get out of the exponent with the arrow and hit enter. So I get 6455. Let me write this down. Equals 6455.608 dot, 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 dot. If you go back to the instruction or the question, the other thing to note here is it does say round to the nearest dollar. And so if I take the answer that we got of 6,455.6 and round it to the nearest dollar, I'm going to have $6,456 would be the approximate value of the boat after 7 years. Okay, the next question asks you which of the following is the graph of the exponential function 6 to the x power. Now, there's several approaches you can take here. You could set up your own XY table and think about plugging numbers in. Okay, the negative might be a little tricky. We know that 6 to the 0, anything to the 0 power is 1. 6 to the first would be 6. 6 to the negative 1, remember we would invert that, so we would have 1/6. So I need to look for the graph that has the ordered pair 0, 1, and 1/6. So if I look at this first one, it does look like I have a point at 0, 1. And it does also appear that I have a point at 6, 1. So this is going to be my choice for now. But just because I think it's the first one doesn't mean I shouldn't check the others. This one does go through 0, 1, but at 1, I'm only a little bit between 2 and 3. So I know it's not this one. Here I'm at 0, 1, but I'm at 1 and somewhere between 1 and 0, so that's not it. And then the last one, I start at 0, 6, so it can't be this one. So of the 4 options that I have, it is the first one. Now, as a side note, the other thing that you can do to help you with this problem is to create the picture in your graph, in your calculator. So I would do 6 raised to the x power and graph it. And again, I can begin to see what it looks like. So because I know that it's kind of that backwards L shape, I could eliminate my the third choice at that point, and then I would have to again look for some other points. Remember that you can look at a table of values. So again, you want to see 0, 1, 1, 6. You could scroll up and get values for -1, -2. Okay, so that's another way to look at that particular problem. All right, the next question, question 4, asks you which of the following graphs is the graph of 8 to the -x. Now again, you could create your own XY table and just use simple numbers like -1, 0, and 1. So 8 to the negative of -1 would be 8 to the first, which is 8. 8 to the -0 is still going to be 1. And 8 to the -1 would be 1/8. So again, thinking about this, I have to have it where the graph intersects the y-axis at 1. So this first graph doesn't do that, so I know it's not this one. The other three are possibilities. I need to point -1/8, so -1/8. That one doesn't seem to have it. Let's see, -1/8, and I have 0, 1. So that looks like a keeper. Here I have 1, +1, and I should be at 1/8, which is going to be somewhere down here. So it's not this one. So in this case, I would choose this one. Again, I can use my calculator as a backup. I can graph y equals, and I can do 8 raised to the negative x power. I do need to get rid of this extra x here. Let's see, let me clear that out. Okay, so I would have 8 raised to the negative x power. And again, I can graph that and get an idea of what it should look like. Now, the difference you have to be careful about is that the scale on your graph on your calculator may not be the same scale on the graph on your picture, but it gives you an idea of what it should look like. Question 5 asks you, what does the graph of log base 3 of x look like? Now this one's a little bit trickier to do, but what you can do is convert this. We know that in logarithmic form this would be 3 to the y equals x. So it's almost easier in this problem to work kind of backwards, and instead of selecting your x's, select your y's. Okay, so 3 to the first would be 3. 3 to the 0 would be 1. 3 to the -1 would be 1/3. Again, you're working backwards because it's a logarithm. So I know that I have to have the point 1, 0, which I have that for the first one. I do have it for the second one. Notice the scales. The scales are changing, so you got to pay attention. Yeah, I got 1, 0. And the last one I do not have 1, 0, so I know it's not this one. I also then want to look for the ordered pair 3, 1. So let's see. 3, 1. That looks good. 3. Nope, that's 5. 1, 2, 3. I'm not at 1, so it can't be this one. 3. This one doesn't even go out to 3, so it can't be that one because I can't see it. Okay, so it has to be the first one. Now again, use your resources and use your calculator as a backup. If you have the TI-84, you can enter the logarithm base 3. Okay, we would go to Math and scroll down. I believe it is option A. It says log base. So I'm going to choose that option. I can enter my base of 3, 4 of x, arrow out of the parentheses, and then graph. And again, you get a picture. Or again, you can look at the ordered pairs on the table within your calculator. So guys, learn to use your resources. But again, we selected the first option here. Number 6 says, what is the range of the function f of x equals negative 7 halves times 5 raised to the x minus 2 plus 1. Okay, so one thing to remember is that the domain for any exponential function is always negative infinity to positive infinity. The range for any exponential function is going to vary depending upon the function. The easiest way to do this, guys, is to create the graph. So put this particular function in your calculator and create the graph. So I'm going to do that. So I go to y equals, I would have parentheses, negative 7 divided by 2 times 5 raised to the x minus 2 power plus 1. And I'm going to graph. Now, I notice that it is inverted. Okay, your exponential has been inverted or flipped, reflected across the x-axis because of the negative. So my range, which would correspond to the y values, if I were on the vertical scale, I'm going from negative infinity up until I hit this asymptote, and the asymptote is at positive 1. Now, if you can't recognize that from the graph, look at the table. Okay, once you get okay, notice the numbers. You're getting really, really close to 1, and then it stays at 1. It never goes above 1. You can kind of keep running the numbers there. So my range here runs from negative infinity up to 1. And the 1 is really not included. It's really, there's an asymptote there. It doesn't really show that on your calculator, but there is. Okay, so it should be open brackets on either end. Then question 7 asks you to find the domain of the natural logarithm of 2x plus 8. Remember that for logarithms, your expression that you're trying to take the log of your that particular value must be greater than 0. You can only take the logarithm of a positive number, and it cannot actually be equal to 0 either. So if I take the expression 2x plus 8, and it has to be greater than 0, and I solve for x, I'm going to subtract 8 from either side. So I have 2x is greater than negative 8. I'm going to divide by 2, divide by 2. So x is greater than negative 4. So my domain would be from negative 4 to positive infinity. Again, the negative 4 is not included because you cannot take the logarithm of 0. Again, it could help you to actually look at the graph. If I look at the graph of the natural log of 2x plus 8, I can visually see that it starts at about negative 4 and keeps going. Again, I can look at the table, and if I notice that I'm at negative 15, I've got errors that I don't actually get a value until I hit -3. Even if it's equal to -4, I'm getting an error. So again, that helps you to recognize, oh, it cannot be exactly -4. Again, use your resources. But remember, the domain for a logarithm has to be positive. It cannot equal 0 and it cannot be negative. So you have to make sure that your expression is positive. Question 8 says to use the product rule of logarithms to write the completely expanded expression equivalent to log base 4 of 6 times 5 plus 6x. Well, what I keep in my mind is that with the product rule converts to addition. So I would basically expand this. It's going to be log base 4 of 6 plus log base 4 of 5 plus 2x. Now you may think you can expand log base 4 of 5 plus 2x, but that is a sum, not a product, and there's no rule that allows us to expand the sum of a logarithm. So that would be my answer. The next question says use the quotient rule to write the completely expanded expression equivalent to. So this one is asking you about quotient rule, and the thing I remember about quotient rule is that the quotient rule converts to subtraction. So I would have the natural log of 6x minus 5 minus the natural log of x plus 4. Again, neither of those expressions can be expanded further because, as we just talked about, there is not a rule that allows you to expand a sum. Similarly, there's not one that allows you to expand a difference. So this would be your answer. Question 10 says, which of the following equation uses the inverse property of logarithms correctly? Okay, remember the inverse property is similar to the idea that addition and subtraction cancel one another off, or multiplication and division cancel one another, squaring and square root. So an exponential and a logarithm of the same base will cancel one another off. So if I have base e exponential, natural log, base e logarithm, they will divide out, and I have 10 equals 10. So this one does work. Natural log, which is base e of 10 to the e. Nope, that's not a natural log and an exponential with the same base. That doesn't work. Natural log, which is a base e of exponential base e of 10. That one works. They're both the same base. So this one would be accurate. Logarithm of 10 raised to the e power. That doesn't work either. Okay, you have to have your logarithm and your exponential have to have the same base in order for the inverse property to work, and we use that inverse property when we're solving equations. Question 11 asks you to use the change of base formula to evaluate log base 9 of 2 and to round to 2 decimal places. Okay, so if you'll remember the formula change of base, if you have log base b of a and you want to change it to base 10, it's going to become log of a divided by log of b. Or you can use natural log. It doesn't matter whether you use natural log or log base 10. So in this case, if you think about it in terms of that formula, in that formula, okay, my A is 2 and my B is 9. So I'm going to have log of 2 divided by log of 9. Now, guys, you have to be careful entering that into your calculator. Okay, so let me show you how to do that. Okay, so we would have log of 2. Make sure you close the parenthesis for the 2. Then divide by log of 9 and close its parentheses. If you leave the parentheses open at the beginning, you're going to get the wrong answer. Okay, and it gives you 0.31546, and it asks us to round. Okay, so we get 0.31546. It asks you to round to 2 decimal places. So the 1 is in the second decimal place, but next door there's a 5, so the 5 is going to bump it. So it becomes approximately 0.32. Now, some of you may have that nice fancy calculator like the TI 84 Plus, and again, you can enter, that problem directly. You can go to Math, scroll down again to option A, log base, and I can enter log base 9 of 2. And notice I get the exact same value. Okay, so there's really 2 ways to do it. It depends upon how fancy your calculator is. Question 12 says the intensity of sound is measured on the decibel scale. The equation decibel equals 10 times the log of I represents, the decibel level, where I is the ratio of the sound to the human hearing threshold. A noise registers a decibel level of 29. What is the value of I? And round to the nearest whole number. So this is an application of exponential and logarithms. They give you the formula that the decibel level is 10 times the log of the intensity. And they tell you that the decibel level is 29. So we have 29 equals 10 times the log of the intensity level. And I need to solve that equation for log, or for I. So initially, I'm going to divide both sides by 10 to isolate the logarithm. Since it's log, which is a base 10, and I have to use the inverse property, I'm going to raise both sides to the 10 to the 2.9 equals 10 log of I. And again, the benefit of doing that, remember, is that the inverse property, exponential base 10, logarithm base 10, will cancel one another off. So I have I equals 10 raised to the 2.9 power. And then I can convert that to a decimal, or to, in this case, the nearest whole number. But I need my calculator. So I would go 10 raised to the 2.9 power and hit enter. And we get 794.32. So we get 794.32 dot 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 dot. Again, the instructions ask you to round to the nearest whole. So the 4 is in the whole numbers place. There's a 3 next door, so we leave it alone. So my intensity level is 794, rounded to the nearest whole number. A question 13 kind of shifts gears because we begin talking about rational functions, and it asks about, sorry, that should be question 13, not 12. What is the horizontal asymptote of the graph f of x equals 3x plus 4, all divided by the expression 2x squared, excuse me, minus 5x. Okay, so we're thinking about horizontal asymptote. There are some rules, excuse me, that guide determining the horizontal asymptote. You have to compare the degree, which is the highest exponent of the numerator, to the denominator. And three things can happen. So in this particular problem, the numerator is the top, and the highest exponent there is an understood 1. Remember, there's an understood 1 here on this x. For the denominator, which is the bottom, the highest degree, which is the highest exponent, is 2. So if I compare the numerator to the denominator, 1 compared to 2, 1 is less than 2, so the numerator is less than the denominator. The guidelines tell us that if the numerator is less than the denominator, the horizontal asymptote is y equals 0, or the x-axis. Every time, all the time. Okay, so you need to have those rules either memorized or have them written down in your notes somewhere so that you can refer back to them if you have a question related to horizontal asymptote. The last question on the review has to do with finding the vertical asymptotes. The vertical asymptotes occur at the values of x that cause the denominator to be 0. But you have to simplify the rational expression first, and that tends to be the step that most students overlook. Okay, you have to simplify the rational expression first, just like you would simplify a good old everyday fraction. Now, to simplify the rational expression, you are likely going to have to factor. So if I factor this problem, in the numerator I would have x plus 4, x minus 4. That's the difference of two squares. In the denominator, initially I would factor out an x, and I would have x squared minus 5x plus 4. And then I want to determine if I can factor or break down that piece, x squared minus 5x plus 4, any further. and I believe I can. I'm going to do it by trial and error. So I need a pair of numbers that multiply to 4 and add to 5. So I can use 4 and 1. 4 times 1 is 4. 1 plus 4 is 5. And I want them both to be negative because I want to end up with a negative 5. Now, if you notice, we have an x minus 4 in the numerator and the denominator, we're just going to divide out. So you have a whole at x minus 4 equals 0, which means at a value of 4, there's going to be a hole. There is not a vertical asymptote. It's just a hole in the graph. So from what remains, let's see if I can get another little piece of paper going on here. Okay. What's left after we simplify is x plus 4 I would have x plus, excuse me, x, well, my goodness. Sorry. We're going to have x plus 4 in the numerator over x times x minus 1 in the denominator. Now that it's simplified, now determine the vertical asymptotes. Okay? So I know that x could be 0 or x minus 1 could be 0. Solving each of those for x, I have a vertical asymptote at 0. I also have a vertical asymptote at 1. So I only have 2 vertical asymptotes. Be careful, okay? Please make sure that you simplify that rational expression first so that you don't miss the fact that there's a hole in the graph at the value of 4 because that particular piece divides out or simplifies out. So your vertical asymptotes, there are only 2. There's one at 0 and one at positive 1.